Hello viewers, welcome to Samti's channel for mathematics, and today we have met for a new topic over here that we are going to discuss differential equations. An equation involving an unknown function, one or more of its derivatives, is called differential equation. So when you are talking about differential equations, we are saying that there are equations, but here there is something we call unknown function or unknown variable and one or more of its derivatives. So here there are derivatives, that differentiation is involved. It's called differential equation. So we will have some of the examples and the differential equations to check. From Newton's second law of motion, that talks of a force and being equal to mass multiplied by acceleration, is a typical example of differential equation. So example here, then we are saying force is equal to mass times acceleration. Why are we saying this is a differential equation? It is a differential equation because here we differentiated something to get the acceleration over here. So it is F is equal to m, which is the mass, times the acceleration is gotten from a differentiation. So differentiation of velocity. When velocity is differentiated, we get acceleration, right? So dv dt. So velocity is differentiated with respect to time, and we are getting acceleration over here. Or F is equal to m times d squared, which is s over dt squared. Why are we saying that this s represents displacement? So when displacement is differentiated, right, you are going to get velocity, and if velocity is also differentiated, we get acceleration. So they work in hand during the differentiation process, then we get acceleration. So there is a typical example of a differential equation, since differentiation is involved in the equation. That is why we are saying that a differential equation is an equation involving an unknown function and one or more of its derivatives. So derivatives must be involved in every differential equation. Alright, so we are having other examples over here. So we can say other examples over here. 1. So we can say ay prime plus by is equal to g of t. So here there is an example here. This is the function which is the unknown function y. So it is also called the unknown variable, and it is also the dependent variable. So this is the dependent variable, this is the derivative, the first derivative of the dependent variable, and here is the independent variable. So these are also constants. Alright, so another example here is example 2. y, this means it is differentiated 4 times. It is differentiated 4 times, so you write your 4, meaning it is differentiated 4 times, but in bracket to tell us it is a differentiation, not a mere power or index, plus 10y prime. So if it is 3 or below, we use the numerals, the Roman numerals, but if it is 4 or above, 5, 6, thereabout, then we put the number in bracket to show it is differentiation. Alright, otherwise it will be like a mere power or exponent. Minus 4y prime plus 2y is equal to cos of t. So this is also a typical example of differentiation. Alright, so we are having classification under differential equations. So classification of differential equations. So I'm writing in D meaning differential equations. So they are classified under so many things. They are just 4 over here that we are talking about. The classification is mainly under 4 things. That is 1, they are classified under type of the derivative. So type of derivative, that is either ordinary or partial. So how do we know that it is ordinary or partial? So differential equations can be said that they are ordinary differential equations or they are partial differential equations. So when do we say it is ordinary differential equation or it is partial differential equation? So let us represent ordinary differential equations by ODE. and partial differential equations by also PDE. So this is ordinary differential equation, and this is also partial differential equation. So ordinary and partial. Alright, so what we do is that the ordinary differential equations, they have only one. So only one dependent variable and one independent variable. So one dependent variable here and one independent variable also here. Then we say that it is ordinary differential equation. But when it is having one dependent, so one dependent variable and two or more independent variable, then we say it is partial differential equation. So here there is one dependent variable and two or more independent variables. So that is how it is differentiated. All right, so let's go to the second point here. The second point talks of order, the order of the differential equation, the order of the differential. So here we are talking about the type. Then we are having the ordinary differential equation and the partial differential equation. We are talking about the order. The order talks of the highest derivative of the differential equation. So when there is a differential equation and you want to find the order, then so let's use this, for example, the first one and the second one, to test for our order of the differential equation. So for the first example here, we can say that the order is 1 since the highest derivative is 1. So here the derivative of this is 1. This one is the unknown function or variable or the dependent function or variable. So the derivative or the highest derivative is 1. But when it comes to here, this is the dependent variable, this is the first derivative, this is the third derivative, this is the fourth derivative. So the highest derivative of this second one is 4. So the highest derivative of the first one here is 1. The highest derivative of the second one here is 4. So that is how it is checked. So we say this of order 1 and the second one here is of order 4. Alright, so let's move on to the third one. So the third one talks of the degree. So the degree also talks of the power or index or exponent, right, of the order. So the order means the highest derivative of the differential equation. So if you are having the highest derivative of the differential equation and that order is, or the highest derivative is having a certain power, then we consider the power. If it is power 1, then we say that the degree is 1. So for here, the highest derivative is 1, that is, the order is 1, and there is no power here, so the power is considered to be 1. So this is of degree 1. When it comes to here, to the highest derivative is 4, or the order is 4, so it's considered to be of degree 1, since it is considered to have an exponent of 1, an exponent or a power or an index of 1. So this is also of degree 1. So the degree, we talk of the power or the index of the order or the highest exponent or the highest derivative of the differential equation. But we make sure that when we are finding the degree, we make sure that always, if the equation is rationalized, we need to rationalize the equation to clear all fractions. So if there is any fraction, supposing there was to be any fraction here associated with the derivatives, then the fractions must be cleared off. So you need to rationalize things to clear off the fractions before you can move on to say that the degree is this or that. Alright, so the degree should be noted to be the power or the index of the order or the highest derivative of the differential equation. The fourth one talks of linearity. So when you are talking about linearity, you want to know whether the differential equation is linear or non-linear. So here you have linear or non-linear. So that's what we want to refer to when we are talking about the linearity. So here there are certain rules or instances we obey. So one is saying that when we want to check for linearity, we should make sure that the differential equation is of the first degree. First degree means that the highest derivative should have a power of 1. The highest derivative should have a power of 1. So here we can say that the highest derivative is having a power of 1, so it's of first degree. This two, the second one too, the highest derivative is of a power of 1. This whole thing is having a power of 1. So we are saying that it is also of first degree. Then it means it has started following linearity, whether it is linear or non-linear. So here it has started following being linear. So let's continue with the other rules. So the second one says that then there should be no product. No product means no multiplication of dependent variable. No product of the dependent variable, say y. So let's take our dependent variable to be y and its derivatives. So what we intend saying is that whenever there is a differential equation and there is a product of the dependent variable, let's say the dependent variable here is y and its derivative, then we can say that that differential equation is not linear, since there is a product of dependent variable and its derivatives. But if there is no product of the dependent variable and or its derivative, then we can say that it is linear. So let's check the other rule. The other rule also say that no transcendental variable, say y. So here we even want to focus on functions, right, and not just variables. So no transcendental variables or functions. So let us use functions rather. No transcendental functions. That is transcendental functions. We talk of trigonometry, so trig. We talk of logarithm, so log. We talk of exponential functions, so exponential functions. So of the dependent variable, and its derivatives, So what we intend saying over here is that you make sure that there is no transcendental function like the trigonometric function or logarithmic function or exponential function of the dependent variable and its derivatives. So follow our next video to watch examples of nonlinear and linear functions or nonlinear and linear differential equations. So let us follow our next video to watch that. Look for it. Make sure you subscribe to this channel if you're new here, and comment, share, and we shall meet next time. Bye. Alright viewers, thank you very much. Please subscribe for more videos from this channel. Bye.